So the next analytical method that I want to take a look at is nuclear magnetic resonance, specifically in the context of proton NMR. Now, this is another qualitative tool, like mass spectrometry, where we want to understand the nature, the structure of a molecule. NMR, nuclear magnetic resonance, refers to the way that the nucleus responds to a magnetic field. So on the exam, you'll basically only ever deal with proton NMR, but to the extent that carbon NMR will show up, the principles will be the same. So all NMR relies on certain core principles, which may be given to you as carbon NMR or proton NMR, be the same thing. Okay, so what's happening in NMR? The nuclei of atoms are spinning in a particular direction. And when a magnetic field is applied, the nuclei will either align, they'll either be misaligned or aligned with the magnetic field. They will align according to how the magnetic field is set up. And we can detect that absorbance or release of energy as the magnetic field is applied and released. Okay. That intricate detail is beyond the scope of the exam. What we need to recognize is that they're subject to a magnetic field, and the pattern of the recognition. So atoms, hydrogen atoms for proton NMR that are equivalent will be detected as a single group. For example, on methane, each individual hydrogen atom is the same. Right? They're all the same. They're indistinguishable from each other. And so in NMR, they'll just be detected as a single peak. They're just a single group. Now, their strength is going to be different because 4 hydrogen atoms will have a stronger magnetic field than 3. And so we'll be able to detect that by the size of the peak. The more area there is under a peak, the more hydrogen atoms it corresponds to. Okay? So that's one thing, is telling the area under the peak and how many hydrogen atoms that corresponds to, how many hydrogen atoms are completely identical. That's the first aspect that we need to understand. The second aspect is symmetry with adjacent, I shouldn't say symmetry, but the presence of adjacent protons, if we're looking at proton NMR. So the more adjacent hydrogen atoms there are, that is, the more hydrogen atoms that I have right next to this atom in question, the more peak splitting I'll have. And so I'm going to show this to you so that you can actually see this illustrated. But for example, if I have 2 hydrogen atoms on an adjacent atom to the group in question, it'll have a peak splitting of 2 plus 1. It's always an n plus 1 multiplicity. So the peak splitting minus 1 tells me how many adjacent hydrogen atoms there are. So let's take a look here at ethyl acetate. Okay. Let's first look at the green carbon atom, or the green hydrogen atoms. So there's 3 hydrogen atoms here, 1, 2, and 3, and they're all equivalent, right? They're all equivalent hydrogen atoms. There's no way to distinguish them. So they'll show up as a single peak. And how many adjacent hydrogen atoms are there? Well, there's only 1 adjacent atom, and there's no hydrogen atoms attached to it, so there's 0. So I see a singlet here. N plus 1, 0 plus 1 is just 1. So that's how many peaks I get in my peak splitting. What about the red one? Well, the red one, I have a CH2, I should have a peak height of 2, or peak area of 2. And you can see on the left, there's no hydrogen atoms attached. On the right, there's 3 hydrogen atoms attached, so I should get an n plus 1, 3 plus 1 splitting, for a total of 4 peaks. So I get a quartet. And then for the blue one, I have 3 hydrogen atoms, so it has a peak area of 3. There's nothing on the right. On the left, there's a carbon atom, and it has 2 hydrogen atoms, so n plus 1, 2 plus 1 gives me 3, so there's that. Okay. So with that, we can see the peak area and the peak splitting. Now, you will, for the vast majority of cases, not be asked to interpret these graphs. You don't need to know the individual chemical shifts. So you would have learned those in undergraduate organic chemistry course. You don't need to know individual chemical shifts and memorize those. But you would need to analyze the peak area and peak splitting information. Now, the peak area information you can't just tell from the graph, right? Because that requires actually measuring the area under the curve, and you have no tools to do that. So they'll actually tell you, the peak area for this one is 3. The peak area for this one is 2. The peak area for this one is 3. So they'll actually have to tell you that, and they'll usually tell you the peak splitting. With that information, you can figure out what the structure would be. So let's try this molecule, or this problem. Okay, so this is an NMR spectrum, some unknown molecule. The peak areas are given. So peak area of 2, peak area of 3, 2, 3. So let's try to correlate some of these functional groups. I like to deal with the singlets first, because the singlets are going to be just CH2, CH3 that are alone. They have no hydrogen atoms on any adjacent atoms. So the only ones that could correspond to a singlet would be this CH3 with a peak height of 3 and this CH3. None of the others would, because all of the others have, even for C, there's a hydrogen atom here, so to at least be a doublet. This carbon atom and this carbon atom, neither of them have hydrogen atoms attached to them. They're both only attached to other carbon atoms or oxygen atom. So that would give me a singlet. So no, I know my answer is either A or D just by virtue of having this singlet here. Now what else? I have another CH3 group, which is a triplet, so it must be attached to a CH2. So it's a CH3 attached to a CH2. That's both of these. Both of these are attached to a CH2 right here. Okay. So I still can't really differentiate these two. Let me color code these so it's easy to track. These are all plausibly the correct associated peaks. Now, this one looks like a big mess, so I don't want to think about that one right now. Let's look at this one right here. So it's a CH2, and it has 3 peaks, so it's a triplet. With my multiplicity, it'll be 3 minus 1. I have 2 adjacent hydrogen atoms. So it's a CH2 with 2 hydrogen atoms next to it. And that's going to correspond to this group and this group. Those are both CH2s, 0 hydrogen atoms on the left, 2 hydrogen atoms on the right, so it gives me a triplet. So far, I still can't differentiate them. And then I also have, finally, I'll have to deal with this peak right here, 2, 4, 6 peaks. So I have 5 total hydrogen atoms adjacent. It's a CH2 with 5 hydrogen atoms, so that's these ones. 2 on the left, 3 on the right, that's a total of 5. Both of those pink groups are CH2s. So that's it. The answer then must be A, because it's the only one where I've accounted for all the hydrogen atoms. You can see that with D, I have not accounted for this CH2. There's no peak associated with it. And so therefore it can't be that peak. I should have some singlet with a peak area of 2, and I don't have it. Okay? Now, that was the brute force method, where we actually had to evaluate each of the individual peaks, and that wasn't. Maybe you had fun with that, which is great, but it's not that much fun having to do all that work. What you can also notice here is that if I have a peak height of 2, peak area of 2, rather, peak area of 3, 2, 3, there's a total of 10 hydrogen atoms there. So I know that my compound must have 10 hydrogen atoms on it. Now, it won't necessarily always be the case that you can do this, but in this case, and there's almost always some trick, some back door for a lot of these problems. In this case, A is the only one that has 10 hydrogen atoms. Count up the hydrogen atoms on each of the individual molecules, and you'll see that A is the only one that actually has 10. So just by counting the number of hydrogen atoms, I can figure out what the correct answer is here.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you've found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.